Hi, I hope you all are doing well. I am into my quarantine time and I'm making it here at home. But I really do miss all of you a lot. Um, Today's my first day where everybody is back at school and back at work. So I'm feeling a little lonely, but I'm making it. I do have my two puppies here keeping me occupied. They're actually causing more problems than helping. So I apologize if they start barking. They're barking at everything. And my daughter's cat was just here to kind of stir the pot too. So this video could be interesting. Hopefully not too interesting though. So for your practice work page, you will want your periodic table out and a calculator. And I'm going to work a couple of these out with you. So if you could go on and have your worksheet out and you can be adding them as we're going along. Okay. So Okay, a couple of things I wanted to note on your copy real quick is the difference between mass number and atomic mass. So the mass number will be your number of protons and your number of neutrons added together. Or you can think of your atomic number plus your number of neutrons to give you your mass number in this column here. The last column with the atomic mass, this is where I want you to put the number that appears on the periodic table, including all of the decimals. Okay, so let's take a look first at the TI. So TI, its name is titanium. Its element symbol, of course, is Ti. You go to the periodic table to look up its atomic number. That's your whole number. That will be the number right above your element symbol. So that's 22. It has 22 electrons, so that means that it will not have a charge. It's an atom, not an ion. Our number of neutrons is where we're going to take our mass number, 50, minus our number of protons or atomic number, which is 22. So 50 minus 22 gives us 28. The atomic mass for titanium that appears on the periodic table is 47.867. So this is actually going to be an isotope because the atomic number and the mass number are different. Okay, so when we write the isotope notation, this is where you're going to write the element symbol. You're going to put the mass in the upper right-hand corner. So we said the mass was 50. The atomic number is going to go in the lower left-hand corner, which is 22. And since your number of protons and electrons are the same, you will not have a charge. Okay, so again, this is your mass number, this is your atomic number. So let's take a look at our next one. So to determine what element is in our second example here, we're going to focus on the atomic number 73. So we're going to go to the periodic table and we're going to find the element that has the atomic number 73. And that is tantalum. The symbol is Ta. We said the atomic number was 73. Notice this time your number of electrons and your number of protons are not the same, so we're working with an ion. The atomic mass, let's go on and add it real quick, is 180.95. So we're just going to put down first the information that we can find looking at the periodic table. To figure out your mass number, remember your mass number is going to be your number of protons plus your number of neutrons. So we're going to look at our atomic number, which is your number of protons. So 73 plus 108, that's going to give us the mass number of 181. So this is not an isotope because notice their masses are going to be the same. It's the mass that appears on the periodic table. It's not different. Unlike titanium, its mass number and atomic mass was not the same. They were different. So this was an isotope that we have of titanium. This is the mass that appears on the periodic table for tantalum. So let's go on and draw the isotope notation. So first write the element symbol. Our mass is going to go in the upper left-hand corner, so 181. The atomic number is in the lower left-hand corner of the symbol, which is 73. Now, to figure out your charge, you're going to look at your protons and your electrons. So what's the difference between your protons and your electrons? So that's going to be a 5. What do you have more? More positive protons or more negative electrons? More positive protons. So that means it's going to be a charge of 5, positive 5. So remember, you could put plus 5 or 5 plus. Either way is fine. Let's skip down and take a look at this example down here of carbon. So we have carbon. Its element symbol is a capitalized C. Please notice that with your elements where the symbols have 2 letters, the first letter is uppercase, the second one is lowercase. So when you're writing your element symbols or typing them, please make sure I can tell what's upper and lowercase. The atomic number of carbon is 6. Since we're looking at the charge here in our symbol, we're going to start with 6 electrons, but we're going to do the opposite. We're going to add 4 electrons to our numbers. So that means we're actually going to have 10 electrons. And does that make sense? What do you have more of? More positive protons or more negative electrons? Negative electrons. So that's -4. Remember, atomic number is the same as your number of protons. To find your number of neutrons, we're going to take 13 minus 6. So that's going to give us 7. And our mass number is going to be 13. And the atomic mass is going to be the number that it appears on the periodic table, which is 12.011. So this element we're looking at is an isotope. We call this carbon-13. Carbon-12 is the one that appears on the periodic table. So if you could go on and jump back up here and finish helium, gallium, and then our next two elements. Down here at the bottom, you're going to calculate the atomic mass unit, or AMU, for your three elements that you're given. In our notes, we looked at chlorine. We had chlorine 37 and chlorine 35. So I went on and added the formula. So you're going to take your percent abundance times the mass of each one of your elements, and then you add those up, and that's going to give you your AMU, or your average atomic mass unit for your elements. So in this case, in our first one, we have boron has two naturally occurring isotopes. We have boron 10 that has the abundance of 19.8%, and the mass of 10.01 AMU. And boron 11 has the abundance of 80.2% and the mass of 11.09 AMU. Calculate the average atomic mass of boron. So what we're going to do is we're going to change the percents back to decimals. So we have boron 10, its abundance is 19.8%. So that just simply means change that to a decimal. So instead of 19.8, we're going to have 0.198. That's your percent abundance times its mass. And its mass is 10.013. So your next isotope is boron 11 that has the abundance of 80.2%. So we are going to change that to a percent. So we have 0.802. We change our percent back to our decimal, 0.802, times its mass, which is 11.009. So when you take 0.198 times 10.013, you're going to get 1.98254. And when you multiply 0.802 times 11.09, you'll get 8.829218. Add those together. Oops. That is your AMU, or your average mass unit, or atomic mass unit. So it's 10.811792. So if you look at the mass of boron on the periodic table, you're going to see that we have 10.81. So that's how that mass was calculated for boron that appears on the periodic table, because you cannot have parts of protons and neutrons. It's a weighted average. So that's how you will calculate. The other three problems, or excuse me, the other two problems, we'll be using this formula here. I do want to point out on number 3, you have 3 different isotopes that you're going to be using. It's going to be set up just like this, where you're going to find take the percent abundance times the mass for each of those 3 isotopes for magnesium, and then add all 3 of them together.